All right. Then we'll talk about a couple other sampling methods that we already talked about a little bit, like stratified. We did some stratified sampling in the cornfield, and there's one other type that you need to know. It's called cluster sampling. That's similar. All right, what's important to get down here is what is in the green box. An SRS of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected. Go ahead and write that down. When you're done just writing that down, give me a green check and I'll answer that question at the bottom. All right, and we also kind of introduced this question in the bottom when we did our sampling in the cornfield activity, which is what's the difference between sampling with replacement and sampling without replacement? And the answer is, so sampling with replacement means repeats are okay. And then sampling without replacement means sampled individuals must be unique. Okay. And it varies. I mean, you can have either depending on the context. With the cornfield, we can't harvest the same plot of corn twice. So we had to sample without replacement, right? But depending on the context, it may be okay with you to sample with replacement. All right, so how do you account for this difference when using a table of random digits or another type of random number generator? If repeats are okay, same values can be sampled multiple times. If repeats are not okay, you would just ignore or toss out repeated values. All right. Any questions over that? And I think you'll get more context once we actually start doing examples of sampling. But so how to take a simple random sample. With technology, that just means with the random number generator in your calculator. You would give each individual in the population a distinct numerical label from 1 to n. So capital N represents your population size. Remember, you have to describe this in detail. So how are you going to label your population? Let's say I need a sample of 30 students from our school. I could say label students individually by last name, alphabetical order from 1 to 830 or however many students we have on campus. But you have to be that specific. And then 2, you're going to randomize. So you're going to use a random number generator to obtain n different integers. So lowercase n, that's your sample size. and different integers from 1 to n. Now, they only need to be different if you're sampling without replacement, right? There may be contexts where they don't need to be different, and you can have repeats in your sample. All right. It's a little different when we're going to use table D. Since table D is a table of random digits, the labeling is different. You have to give each member of the population a numerical label with the same number of digits, because you have to go through counting off the same number of digits each time so that everybody in the population has an equal chance of being selected into the sample. So here's what I mean by that. If, again, I'm trying to take a sample of students from our school, and there's 830 students at our school, I would have to label them alphabetically 001 to 830. So that when I'm actually going to take my sample, I'm always going through the table, taking 3 digits at a time. So then it says, read consecutive groups of digits of the appropriate length from left to right across the line in table D. Ignore any group of digits that wasn't used as a label or that duplicates a label already in the sample. Stop when you have chosen n different labels. So a couple of things that they said there. Because it's a table of random digits, if this is my labeling, I only have 830 students. If I took a group of 3 digits that was 926, that's outside of my labeling domain. I would just ignore that, right? And move on. And I would just take groups of 3 numbers until I got a sample of size n, which for me was like 30 in my little verbal example here. So until I got 30 unique 3-digit numbers that fell between 001 and 830. And again, unique only if you need to sample without replacement. If it's okay to sample with replacement, maybe you don't need unique. That always depends on the context of the problem. I just want to share with you what table D looks like. This is it. So it's literally just a table of random numbers. Now, a couple things about this. The numbers in the first column are not random. So don't use those when you're trying to select a sample. That's the label of what row number it is. The only reason they're grouped like this in groups of 5 digits is just to make it easier to read so you don't lose your place in the table. And so when you would be selecting a sample, you would just start left to right. And if you finish one row and you still don't have your sample, you keep going. They're not grouped in any order. So like if we were taking samples of 3 digits, like in my trying to choose a sample of 30 students from our school example, since there's 830 students at our school, I had to label each student using 3 digits. Let's say I got to like here, right? And I go 285. Okay, so that gets selected into my sample. Then 373 is the next one. So it's not like you're allowed to wrap around. The gaps, the lines, the rows, the gaps between the numbers don't mean anything. Okay, it's just to make it easier to read. And I think that's it. So generally when you come across problems like this in your problem set or on the formative assessment or the exam, what's going to happen is they'll just give you an excerpt from this table. So they'll give you like lines, 121 to 122, and then a scenario and ask you to choose a random sample using that little excerpt of lines. So you won't ever really need the full table. But there are most of the time questions on the AP exam where they do give you a little excerpt from this. and questions where they ask you to describe how to do it using your calculator. So you just have to know how to do both ways. All right, so let's move back to our notes. All right, so let's do an example of this. Remember malls? So this is a scenario where a management of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. And we're going to use table D starting at line 101, which is our first line, to select a simple random sample of 3 stores. Okay. And so let's describe our labeling technique first. So I'm going to say label. I think the easiest way to do this, just because this is the way they're listed anyway, is, and there are, shoot, how many stores total? One, two, three, four, five, six, 7, 14, 21 stores. Okay. So here's what I'll say. Our population size is n equals 21. The sample size we want to get is 3. You generally want to use like when you're using table D, the labeling mechanism where you can use the fewest digits possible to label. So let's say our sample size was 100, or sorry, our population size was 100. What if there were 100 stores? In the chat, how many digits would I need? What's the minimum number of digits I would need to use to label if I'm using table D, if there are 100 stores? So you think 3 right off the bat, right? But couldn't you label from 00 to 99? And that would allow you to use 2 digits instead of 3, right? So you'll often see that when it's like, a round number, like 100 or 1,000. Like 1,000, you could use 3 digits instead of 2, right? For your population size, because you could go from 000 to 999. But in this case, it's 21, so we have to use 2 digits. But I just wanted to give you that little trick. So since I'm going to have to use 2 digits anyway, I'll just do 01 to 21 alphabetically. All right, we're going to select three unique values between and then we'll survey all right. So let's get into it. We'll take our sample. We're going to practice doing it from line 101. So let me reshare that table. All right, so here we're selecting 2 digits at a time. If those 2 digits fall in our domain, we'll select it in. If not, we'll just ignore it. So 2 digits at a time. Line 101, we're starting here, 19. That's in our domain, right? Okay, so that goes into our sample. So we got 1922, that's outside of the domain, so just ignore. 39 outside the domain. 50 outside the domain. And what I usually like to do as I do this is I'll just cross them out as I go. 39, no. 50, no. 34, no. 05, I'll circle. That isn't our domain. All right, 75, no. 62, no. 87, no. And then 13, yes. Okay, great. Okay, and then let's translate this to what are the stores that I'm going to be surveying. So I guess this would just get labeled this way, 01, 02, and so on, and this would be 21 over here. So what's the first one? We have 05. So 3, 4, 5. Okay, so Carter's. And then we have 13. So that's 6, 7. 13 is going to be Mrs. Fields. And then 19, so I'll just count back. 21, 20, 19, Star Jewelers. And that's it. That's who I would want to survey. Cool. Questions about that? Which we already discussed when we did the corn activity. To get us stratified, you first will separate the population into groups of similar individuals. And when I say similar, I mean you expect them to have a similar response to whatever variable you're trying to study. Then you choose a simple random sample from each stratum, and combine these to make your overall sample. So in the cornfield example, we stratified by column. We took a simple random sample of one plot from each column, and then we combined all of those plots to form our overall sample, right? If you guys were trying to create teams for what's that called? Retreat, all school retreat. You want to ensure that there's students from each grade level on each team, right? So what you would first do, you wouldn't just take a simple random sample of 30 students from the school, because you could end up with all fifth graders or all juniors. And you want representatives of each grade level on a team. So you would stratify by grade level. You would take a simple random sample of whatever 4 students from each grade level, and then you would combine those to make one team that has students from each grade level, right? So when is it beneficial to use a stratified random sample? So when the population differs by a certain variable. that you need to account for or that you want to account for? The benefit is that you ensure representation for individuals with different values of that variable. And you choose the variable by expectation of differing outcomes. So in the corn sampling activity, we go, oh, maybe the river is doing a better job of getting nutrients to the corn that's closer to it. So we stratified by a vertical column with the expectation that columns further from the river were getting less nutrients than columns closer to the river, right? All right, a cluster sample is going to sound similar, but it's different. So remember that in a stratified random sample, you first stratify, you separate that into groups of different variable values. So like for my school example, you separate the students into grade level groups. Then you take a simple random sample from each of those groups and combine those to make your overall sample. In a cluster sample, you first will group population into groups of individuals that are located near each other, called clusters. And they're not supposed to be the same by any variable. You would like them to be what we call heterogeneous groups, meaning they should differ by all variables. You'd like them, the clusters ideally should be little representative samples of the entire population. And then to get your overall SRS, what you'll do is label the clusters, and you'll take a simple random sample of the clusters themselves. And you'll use every individual in the clusters that you select. So I guess to keep my analogy with school, let's say now you're just trying to get a representative group of school students and you need like 60 students, right? And you guys had already created the teams for all school retreat. Let's pretend that. So usually we have like what, 25 teams of like 30 students each or so. Each one of those teams is a cluster, okay? Because they're all little representative groups of our school, right? They all have students from every grade level. So each team is heterogeneous because they differ by all variables. We have multiple genders represented in each group. We have multiple grade levels represented in each group, etc. So what I could do then, if there are 30 teams, I could go, okay, I just need 60 students to represent the school. I'll label the teams 1 to 30, and I'll take a random sample of 2 teams, and I'll just use everybody in those 2 teams as my sample. So each team is a cluster. I take a simple random sample of the clusters, and everybody in those clusters that I select comes into my sample. Does the difference between that and stratified make sense? All right. Give me a green check when you're good with this page. Are we okay with selecting the same book twice, or would we want unique? Yeah, I would agree. Unique. So 500 unique. Values 1 to 20,000. Find the books with those labels and compute the mean number of pages. All right, so this could be problematic for a couple of reasons. One, simple random sample. If there's a lot of variability in length of book by a certain variable, in this case, what I think they're trying to get at is generally the length could vary by subject or style, right? Like, so fiction versus biography versus history versus like a science book may have different averages. And if you're taking a simple random sample, you run the risk of getting a large number of the same kind of book, and that style of book is overrepresented in your sample, which will then maybe give you, not a good estimate for the mean number of pages. It's also going to be very, very time consuming, right? Because if you have to find 500 individual books that are in different parts of the library, you're going to spend a lot of time going to select those books individually. So then we can try stratified. And keep in mind what I just said. What variable do you think we would want to stratify by? Yeah. So I might say stratify by genre. Select a SRS. In this case, they don't tell us how. We would need to know how many genres there are and how many books are in each genre. So I'm just going to be pretty general. Of appropriate size from each genre to obtain a sample of size n equals 500. And that may mean, right? So if there's more fiction than anything else, then you would want fiction to be more representative. So you might be taking a simple random sample of a different size proportional to how many books in the library fall into that genre, which is exactly how they'll do political polling, as we've talked about, right? If one county is 60% Republican and 40% Democrat, then when they do political polls, they want to make sure that they have that same proportion of Republicans and Democrats in their sample, so that it'll be representative of the county. And it asks why this method, and we can just say page length or page count may vary by genre, right? And so a cluster sample of 500 books, they'll usually put genres together, but they may be there may be multiple genres in multiple aisles, right? Or in the same aisle, I should say. And so that's why it may be appropriate to do a cluster sample. Um, and in this case, they're saying shelves hold about 50 books each. So we'll cluster by shelves, by shelf. And so if there's 20,000 books and shelves hold 50 books each, 20,000 divided by 50, there's going to be 400 shelves. We'll label the shelves 1 to 400. Take an SRS of, if we want 500 books, 10 shelves. Use all books from the selected shelves for the sample. And the main reason we would do this is that it's convenient. We don't have to go all over the library back and forth picking out 500 individual books. We just have to go to 10 shelves, take all the books off that shelf. They probably are, but I think the idea is that shelves can hold multiple genres, like it can switch over in between one shelf, right? But that would be a drawback of the cluster method is you're likely to get a less representative sample, uh, especially when it's not grouped. They're probably grouped more homogeneously, meaning like you're right. You're more likely to have shelves that are one genre. So that would be a drawback of the cluster method. So I would say cluster likely less representative. But this is something to take into consideration with real life statistics is that sampling costs money because it takes time, right? And so you have to kind of balance between time and cost and sort of giving up maybe a more representative sample. So if you think the cluster sample was likely to be reasonably representative and it's going to be way more convenient, then maybe you want to go with that. A drawback of stratification. It's going to be more calculation. You have to figure out how many genres there are, right? Like, and then also what proportion of the pop each genre has, and then make sure that your simple random sample from each genre is proportional to the amount that genre takes up in the library. So it's more calculation, a little more time consuming in that respect, but still probably a little easier since you would expect the library is already sorted by genre. And then the big one with a simple random sample is it's going to be super time consuming, and it may over or under represent certain genres. Okay.